Up, Bob pops up behind.
Yeah, yeah, exactly. So we're live, just by the way. Yeah, I agree. And one of the things that I want to do is make this whole thing more mobile. Because doing it out of my home, having the mixer, having all the setup and equipment and everything is fine, but it doesn't necessarily lend itself to, hey, we're going on the road and
Yeah,
broadcasting from
you and me
someplace
both.
unfamiliar. So I need a mobile setup.
I want a mobile setup too. I need a highly mobile development workstation.
Yeah, yeah, yeah.
That's for me. That's my need.
No, I totally
The
agree.
mobility
I
part.
want you to have one too.
Yeah.
Don't we all need one of those?
Yeah, absolutely. And
In
and I,
addition to a villa in whatever.
and I've been working towards that. I feel like I have. You could certainly do that with a. What am I trying to say here? A Surface, a Microsoft Surface. You could have your drawing tablet and your development environment all in one. I bought an iPad Pro because I'm more in the Apple camp of things, and I think I finally have a setup to where I can do have a tablet and a workstation. And now with this microphone, I feel like I have more of a mobile studio. So yeah, absolutely. And don't think that your last comment there, Ed, went by. I definitely little umbrella drinks. Uh, you know,
That's great.
shine.
I'll get a lot of work done with the waves rolling in. Sorry. Just imagine,
Uh, yeah, absolutely. Well, hey guys, thanks for being here. So I'm going to go ahead and just intro the show, just for those who are watching uh, the whole live hangout previous, after it's been recorded, and and that sort of thing. So kind of a going back a little bit to what we used to do, but you know, whatever. Still working out the plan. Still working out the mojo here. So, all right.
All right.
All right, everybody, welcome back to Corona Geek, here where we talk all about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and today we are going to continue our development series. We've been doing a twin-stick shooter development series, and we're going to continue that with some more deep dives into different bits of the code. So one of the things that we've been doing in the past, well, actually in 2015, we did a whole bunch of development series. So if you haven't checked that out, go to coronageek.com, or you can find them over at youtube.com/coronageek. All the video series are there. Basically what we've done is we've gone everything through a platformer. We've looked at popular games. Zigzag Boom was one of them. And we've looked at all these different, like the mechanics, how the apps are structured, how to do level screens, and how to do a variety of different things. So we're continuing with this development series here, but what we've done in this time is we've actually, instead of focusing on the whole game and all the different pieces, we've just focused in on select pieces. So you can download the code, the links will be in the show notes, and you can go through everything on your own, but we've just taken sections and highlighted those because we've been through these development series so many times that we're not going to go through, how to do the composer scene management, how to do game over screens, how to do restarts, that sort of thing. We're just going to focus on the things that are new and interesting. So that's what we're going to do today. Joining me on the panel is Ed Marina from RoamingGamer.com. Also, we have Mike Hempling from CraveCreative.com. And joining us just here at the last moment is Sergey Lurg from SpiralCodeStudio.com. Hey, I nailed it this time. I actually remembered.
Yay!
I remember the domain this time. Hey, you still don't have your avatar worked out, huh? Or your camera?
Yeah, not
Hmm.
today.
Okay. Well, that's
Maybe
all right.
next time.
That's okay. We still love you. We're glad you're here.
Awesome.
Awesome. So, does anybody, before we get started, anybody have any announcements that they want to share on the Hangout?
Oh, I was working on Corona Canon demo project, and this is now public. You can download it and use it if you like it.
Absolutely, yeah. That's a great. And does it work on Apple TV? I didn't get a chance to test it over the weekend.
Yeah, it does work on Apple TV. It works on OS X, on Windows, on Android, on iOS. I haven't ported it to Windows Phone, but the porting is pretty easy.
Okay, well, that's awesome.
I have an
Yeah.
Say
announcement.
again,
I have a
Marcus?
quick announcement.
Oh, okay, go ahead.
Um, that is that alien spacecraft, which was originally released on Android and iOS. I got that accepted on Saturday to the Apple TV. So it's just basically a real simple side shooter game.
So how was that a whole experience for you?
Because both games that I've done now have been really simple. One was the Flappy Bird type one, Flappy Fruit Bat, and this one with Alien Spacecraft, which is very simple side scroller game. It was super easy to do. The hardest part in the beginning was being able to keep the local scores, which with the iCloud plugin, that's how I was able to do that for both games, and that worked flawlessly, and they accepted them that way. So
it's exciting to see all these Apple TV apps being published. I've seen several on Facebook where people are like, "Hey, develop this with Corona, Apple TV. Check it out." So
inside Corona Canon example, there's a library that I made. It's called Data Box, and it is using iCloud storage and a file in Documents directory. So you just plug it in and you store your settings on all devices, and you don't have to do anything extra.
Oh, that's
So
going to
check
get
it out.
stolen by me.
Hmm?
I'm looking at your code now. I shouldn't do that during the show.
Oh.
So, Sergey, you're doing this Corona Canon. What other? I know you're reworking some of the other examples. What other examples are out there?
There are many examples, and I'm not sure which one I'm going to work on next. So that's to be discussed.
Okay. Well, yeah. Just so everybody knows, there's previously there was a bunch of sample code that have been created over the years, and some of them were updated, some of them weren't, some of them were in different places, some of them were centralized under the Corona Labs repo on GitHub. And so what we've done is we've pulled all that. We're working on updating everything and then publishing it all out of the same central location. That way, it'll be easy to find, it'll be up to date, and everybody will be happy. So Corona Canon is definitely one of those. That's the first one out of the box. Works on Apple TV and also on other devices as well. So we'll put a link to that in the show notes. And Mike, if you would, give me a link to your game. Will you drop it in the chat?
Okay, yeah, I can do that.
Yeah, and then that way I can put it in the show notes as well. Ed, did you have anything that you wanted to share before we moved on?
I have no announcements on anything that is out yet. I am working on some things, but I am not ready to announce they're done. So next week.
Okay. I have a couple of quick announcements here. One is if you haven't paid attention to the blog here lately, I highly recommend that you do, because there for a while, things were getting a little bit repetitive. We had kind of the Corona Geek announcements, and then we had a Tuesday tutorial, which are always great. And then we would have from the forums, by Alex on Friday, which are awesome as well. But it was sort of becoming a rhythm, right? It was 1, 2, 3, 1, 2, 3, and now we've got a ton of stuff coming out of the blog. A lot of updates. Everybody's working on things. And we've hired some new resources, and Perk has added some additional resources, and a lot of exciting things are happening. So the blog is got a brand new life on its own. So one of the things that's out there right now, just got published this morning, is the Facebook Audience Network plugin has been updated. Basically, the big change is that there are new rev share ratios, and essentially I'll leave it for you to read, but the general overview of the blog post is that everything is a little more gradiated now, or we call it tiered. Thank you. It's tiered so that if you have a certain amount of impressions starting out, then it's one ratio, and then as your impressions grow, the ratio gets smaller and smaller, or the percentage gets smaller and smaller as you go. So go check that out. If you don't know what I'm talking about, the Facebook Audience Network is essentially Facebook ads. We've created a plugin that we will maintain, and you don't really have to do anything. You don't have to know Facebook's API. You don't have to worry about creating a plugin. We've done all that heavy lifting for you, and then it'll be maintained by us, and all you have to do is just add the configuration settings into your project and tell the fan plugin when you want ads to show up. So they could be banner ads, they can be interstitials, they can be a variety of different formats. So go check that out. There's also a new Corona autocomplete package available for Atom Editor. So one of the things we have is we have the Corona GUI editor, which is a drag and drop editor that's in beta. We also have Corona Editor, which is basically works for Sublime and does autocomplete and things like that. And now we have a autocomplete package for Atom Editor. And Atom is a popular editor. These editors kind of grow in popularity and become the darlings, the shiny shinies that developers like to use. And Atom is the one that's kind of on top right now. Sublime has, I guess, maybe slowed in their updates, as it's matured. And Atom is it has a lot of similar features to Sublime, but now it's it's one that's being used by people a lot. So is everybody still there?
Still here.
I think Sergey must have muted his audio feed. It got really quiet. And
We're all
then
giving you the stage there, Coach.
Yeah. Thank you very much. Well, now I have. I'm looking actually at the blog and not at the Hangout. So you guys could have been gone for all I know. Anyway, so then there's more plugins coming soon. It's all in the blog. There's lots of stuff there, and I'm told that we have work in play to get the actual marketplace portion of our store in place, so that people can submit apps and sell plugins rather, and things like that. So that's exciting too. Nothing official on it yet, but it's in the works. Just know that it's in the works.
Hey, I got a suggestion, possibly, now that you bring up the Facebook thing, for possibly the Tuesday after dark session would be to talk about the whole Facebook tiered system. I saw that obviously there's concerning to developers of the ongoing revenue share that we lose, and if that's fair or not fair. And I think that would be a really interesting conversation maybe for the After Dark show.
Yeah, that would be good, and I think in that instance I would like to try to coordinate with Raj and have him on the show, because he would certainly have a lot to say about that, and would be interested at the same time in hearing what people have to say. It's kind of interesting. One of the things that this particular plugin, there was this ratio model where basically in the beginning, 1 out of every 5 ads would be attributed to Corona, and so that would mean that it was essentially like a revenue sharing model where Corona would make money and the developer would make money. And yeah, you're right. It caused a little bit of controversy. And what's interesting though is that we were completely transparent with that, right? Right up front in the documentation and the blog post, everything. We were like, hey, look, this is what's happening. It's when you succeed, Corona succeeds. That sort of thing. And everybody, I won't say everybody, a few people were very vocal about that, and we appreciate that. And so what I think is the interesting thing is that a lot of times you don't even get to see these partnerships or how things break out. Or you know what I'm saying? Like you don't even get to see the behind the scenes of things. So this is one instance where you do get to see the behind the scenes, and I think that people were a little bit surprised by that. But most of the times, things happen. You don't even get to see you don't even know how things are structured. So it's interesting that the community gets to have a voice in that. So
actually, I don't want to beat the fan thing to death, especially. We'll talk about it later on another show. But 2 things about this struck me. 1, the transparency, as you said. And 2, the responsiveness. So I think those are both healthy signs for where we're at. I mean, I'm talking to the people who are watching the show now, and they probably agree already, but I still wanted to say it. It feels good to me that we got to see what was going on in the back, and then when people started to lose their mind over it, some people, there was a discussion a frank discussion about what was going to happen, and then some changes were made.
Yeah, absolutely. And some of this is evolving as it goes, right? I mean, like I said, the fan plugin in particular is a little different animal than most other ones. In most situations, there would be some sort of back office conversation, some agreements, and some handshakes, and then things would just be part of the way that things do business. And you'd say, oh well, here's a plug-in, I just implement it in my thing, and everybody kind of goes about their business. And the developer would get their rev share, whatever that is to them, but then downstream there would be another conversation, right? There would be that back office conversation I was just speaking about, that where things would be negotiated. So in in some instances, what we're trying to do is make sure that we can get a better deal for developers than they would have if they went directly to one of these ad providers directly themselves. So and at the same time, negotiate directly with those providers and say, hey, we want a business development piece of that as well. So a rev share part of that as well. So it's so the fan one is different because Facebook doesn't have a program. They don't have a way to do the bookkeeping and drop money into people's accounts, right? In that sense, they do it directly to one-on-one with the app developer. So what we did was we did the heavy lifting to say, look at Facebook's API and say, hey, we can provide a service to the developers by creating a plugin that we will maintain over time, and they won't have to know the API. They won't have to know how to develop a plugin. They can just drop it into their app. And as part of that, we would like to figure out a model or a ratio where we would be able to benefit financially and be able to support that and other things, of course, as we go. So it's a bit of a different beast altogether, and not necessarily the norm in a lot of respects. So Sergey says, talk about ads for 2 minutes. I'm going to make a cup of tea. All right, good. There you go. There's your public service announcement. All right. Well, hey, let's talk about twin stick shooter stuff.
Yep.
I know.
Sorry, I had to find my screen there. I got too many windows going on.
Ed, you had emailed me some of the key points that we wanted to talk about, but I, quite honestly, have slept since then. What were we going to talk about?
All right. So I got a list of like as Charles said before we start into the segment proper. We are going to be finishing out this game. There are a number of topics to discuss. Among those topics are using sensors for smarter enemy spawning. We're going to dig into the caching of objects. Today's two topics are smarter enemy spawning and object caching. But then we have a number of other topics. For example, next week we'll talk about, if things go properly on schedule, we'll talk about player weapons and dying and respawning. And then if we have time, perhaps we'll talk about detecting the current platform and configuring your game accordingly. And then after that we have some other things like virtual joysticks and a few other dangling topics. But again, before we start this segment, we're going to be breaking these up into smaller segments. Before we start our next topic, I wanted to point out that this game is functionally complete and available. Now, it doesn't have sound. That's probably the only part of it that is not functionally complete. And the reason I didn't put sound in is because, to me, it's sort of a waste of time for this game. The sound code is in there. You could turn it on. It doesn't do much. It plays a background sound. I got a message on my device.
That was a timely sound.
Yeah, that's just what I needed. Stop. Okay. Oh, okay. Video call from Chris Byerly with 26 others.
Wow.
Okay. Whoa. Stop. Okay, that's just unacceptable. Sorry. Oh, no, you must be... I need...
All your devices going off at once?
Okay, 2 seconds. Everybody, I apologize, but this is...
That's all right.
I think they're trying to get into the Hangout, and they're dinging me. But it's going... This always happens. This always happens. I'm on my computer, but Google says, no, I insist on talking to you on your device.
That's all right. Here, I'll send a link to Chris. Maybe that's what he's wanting to do.
So, long story short here, folks who are listening, as we get our act back together, go ahead and grab the game. It's playable. You can play it on mobile. You can play it on desktop. It automatically detects where you're at. It pulls up virtual joysticks if you are on mobile. So everything is completely functional, minus sound. All right, so today's topic, one of two, is, as I titled it, using sensors for smarter enemy spawning. So let me go ahead and bring up my desktop, and I will show you our current game. And then this will make more sense. All right, so this is our game, Geometry Wars Retro Evolved Clone. And in this game, what I have done for today's example is I've made the entire world very small. And as you can see, I'm floating around here, trying not to get killed. And as I move around, you can see that the grid turns from green to red. And then occasionally you'll see a little bit of a slightly, okay, I'm going to die, a slightly yellow bit occurring. Let me just go ahead and pause here. So what you're seeing is you're seeing red grids, green grids, and then yellow. And the premise of what's going on here is I needed some way to spawn enemies, and I needed to do it in such a way that they didn't just randomly spawn on top of the player, but instead they spawned somewhere nearby that was suitable for gameplay in the sense that they would spawn nearby but not on top of me, and I could detect always where the player was. So as you can see again, let me just start this up. As I move around, the grids turn red, which is an indicator, this is a debug feature that I turned on, which is an indicator that I should not be spawning enemies here. Now, what I decided to do for today's talk is instead of look at this code directly, we will look at a separate piece of code where it's much simpler. So let me take you there, and this will make a little bit more sense. First of all, this code is going to be available downloadable, but it's under the Corona Geek Hangouts Tips and Tricks section on my GitHub, and underneath a semi-inappropriately, I'll probably rename it, but currently it's called Sensors. I'll probably call it something else to make it a little more suitable for today's topic. But right now we're calling it Sensors. And what I've got is a 2x2 grid of physics objects which are acting as sensors. And then I have a little dude here that you can click on and drag around, or tap on and drag around if you're doing this on a mobile device. And as you drag it, you'll notice that the grids change color. So what is occurring is that this little guy, as it moves around, is colliding with the sensors. And when I collide with a sensor, that activates the logic, the collision logic that is attached to the sensor and says, mark this as a illegal space to spawn in. So it's very similar to the logic in the game, but there's no spawning going on, so I don't have to stay alive and talk at the same time, basically. But the essence of this is as we enter a spawning region or a grid element, it turns itself off. It says, this is no longer allowed for spawning. And as we exit, it turns green to indicate that the logic has fired and said, okay, this is now a legal spawning location. So when you have a game like the one that we are making, you have to make decisions such as, where do I place the enemies? How close do I place them to the player? Etc., etc. And there's a number of ways to approach this, but I've found for this particular game, the easiest way to do it is to take our play area. If you imagine our play area for this game just being this square of the green and red subsquares, this is our whole world. Now, if I were spawning, ideally, I would spawn enemies somewhere between the upper left-hand corner and the lower right-hand corner, somewhere in this larger square. And what I've done is I've created little subsectors, and then I'm not doing a very good job of describing this. As much as I get ready for this, I never do a very good job. Give me a moment.
Well, you know, sometimes it's hard to especially if you have an abstract concept, it's hard to convey it, especially when you're trying to do it in code and abstract.
Well, before I look at the code, I wanted to walk through the concept. So I'm gonna quickly start over. So we start over, and our player is in the very center of the world in this case. And so what we're saying is we're not allowed to spawn in any of these grids. Imagine, if you will, however, that we have the game running and there are more grids out here. This is a very small world example. So as soon as the player moves, now we're allowing enemies to spawn here, here, and here in these 3 green grids. And so the way the algorithm works is actually fairly simple. We collide with a grid, it turns it on, and as we leave it, it turns it off, and as we leave it, it turns it on. So if it's green, or if it's marked as on, that's a place where we can spawn. And then every cycle, the game code will go through, and it will say, how many grids do I have that are enabled? Let me find them. 1, 2, 3, 4. It iterates over all the grids, because I keep them in a table, and it says I've got 3 grids where I could possibly spawn an enemy. And then it will randomly select one of these grids and place an enemy somewhere within that subgrid. So it'll say, for example, so it'll select this one that I've made red, and it will say, okay, I can spawn over here, and now I will randomly place an enemy somewhere between here and here, as far as upper left corner and lower right corner, somewhere within this grid, or left to right, top to bottom, depending on how you want to think about it. So to elaborate on this a little bit better with visuals, let's go back and look at the game, and I will just try not to die, and you can watch what's occurring as I fly around. So the game starts, and in our game, what it does is it selects a grid, which then turns yellow to give an indication it's about to spawn an enemy, and it spawns an enemy, and the enemy pauses, and then it starts to give chase. So you notice, as I move around, enemies never spawn in the red grid where I'm at. So if I get in the middle here, you'll see that they just spawn outside of the region that I'm in. So the question for this segue, or segment, is how does this work? So let's take a look at the code. I'll show you how to create a sensor, and then we'll take a look at the game code, and I'll show you how it's used. Let me get my windows up here. For the smaller example, everything you need is in main.lua. And the way this works basically is we do our typical setup at the top. Let's change that to 2016. Let me make this a little bigger so you can read it. We do our typical setup. We turn off the status bar so it's not in the way for our example. I set up the buffering so I get the output in the console right away. We're going to use physics. This requires physics, so I load the physics module or library by saying local physics equals require physics, and I start the physics engine. Then I create a table that's going to contain the individual objects that are part of our sensor grid. So if we go back and look at the example, we have 1, 2, 3, and 4 grid pieces for this very simple example. We have a collision function, which I will come back to. And then we have a builder function here on line 28, which does the work of creating one of our sensors. And this function takes an X and a Y location, a size for the sensor, and then what it does is it creates a rectangle at that position using the size for the width and height. We mark it as can spawn. Initially, we assume that you can spawn in every grid, so if this guy wasn't here, these would all be green. We set the color to green, which is our visual indicator. And again, I shouldn't say again, but in this example, we're not doing any spawning, but I wanted to keep this code as close to the sensor code you see in the game as possible. So these are just indicators. I set the alpha because I didn't want it to be too bright. So for example, if I left the alpha here and reran this, it's just a bit too bright. I mean, I guess some people might like that, but I think for this demo, that's just too much for the camera or for the Google Hangout. And then let's see, I set stroke width to 1, and the reason I did that is because I wanted to show you very clearly that we have 4 little boxes which are covering our play area. Again, our play area is the big red square, the entire space, not anything in the black. Next, we add a physics body, and the reason we add a physics body is because sensors use the physics system for collision detection, but no response. And I'll elaborate on that in a minute. But what we do is we say add a physics body, we make them static, they're not going to move, they're not going to be affected by gravity, and we set the is sensor parameter to true, and that's all there is to it. Then we attach our collision listener, which I'll go back to in a moment, and we activate it with the add event listener collision. And lastly, we put the sensors in the table. So every time we create one, we simply put it in the next slot. So sensors plus 1, or number of sensors plus 1. And then here below, in the example, you see that I call this function 4 times. And I create a grid in to the left and above the center, and then to the right and above the center. So first I create this one, then I create this one, then this one, and then this one. Let's see. Down here, what I've created just for this example is a little counter that will get updated to show us how many of these areas are basically allowed to spawn. So in this case, 3 are allowed to spawn, 2 are allowed to spawn, and none. Those are pretty much the only options, unless we drag off. The way this bit of code works is not important so much to the game, but the example. And what we do is we create a new text object. We attach an enter frame listener, and in short, every frame it goes through and it iterates over the 4 objects that are now in sensors, which is our table that we created above. It iterates over sensors, and it says, whoops, it doesn't say whoops, it says, is can spawn set to true? If can spawn is set to true, we set this little counter to count plus 1. So we initialize it as 0 every frame. We count up for everything, every box that is marked as can spawn, and then we set the text on our little display to whatever that count is. So again, what would occur is as we move around, this value will change depending on how many of these are green or marked as can spawn. Let's see. Okay, lastly what we do is I created a little guy for us to drag around, which is the smiley face. And I created a new image rect using smiley PNG, which is in the root folder. I put it in the center of the screen. I added a body to it, a dynamic body, and I gave it a circular radius so that it's got a collision bounding circle instead of a bounding box. I set the gravity scale to 0 because physics is enabled, and I don't want gravity to pull this down, so if I had forgotten to do this, just for this example, unfortunately this is what I would get. Absolutely no good for our example. Not part of how the code works in the game, but just so that folks understand why I'm doing this. I don't want the character to fall off the screen. I just want to be able to drag it around. And then I added a little touch listener, very simplistic touch listener that says anytime any event comes in, simply move the character to the position of the event. So if I click over here on the character, it will center itself on that click. And then as I drag around slowly, it will follow my mouse cursor or my finger if I'm running it on the device. So the critical part here, the only critical part, is this bit right here. We created a rectangle, we attached a static body to it, and we said it's a sensor. Now what this does is it says these objects are not going to move because they're static. Gravity will not act upon them. They cannot be pushed around or anything like that. But in addition, because we mark them as a sensor, even though this object is colliding, the one we're dragging, it's not actually pushing on them or doing any of that stuff that we normally associate with physics. All it's doing is triggering the collision listener. So I've said this on other shows before, but there's 2 parts to physics, collision and detection, which is there is the collision event, which is an event that this is not something you would normally think of in the world, in real world physics, but in games and other simulations that use physics, we detect that a collision occurs, that is, a collision has begun or ended or is occurring, and that's the detection portion. But then we have collision response, which is the other part of physics in games and in the world. Response is the part that we're used to. So for example, if we have like a basketball and we drop it, it hits the ground, and what does it do? It bounces back up. And that bouncing back up is the response part. It's the part that people associate with physics. But we don't want the response portion of this to occur. So we mark it as a sensor, and what that tells the physics engine is determine that a collision has occurred or not occurred, but don't do anything about it other than say, hey, it happened, or hey, it ended. So let's take a look at our code, which is the on-collision code. So the on-collision code, which is attached to the collision event, will be used for the detection, and all it does is when a collision occurs or begins, it marks that object as you can no longer spawn here. In other words, make it red and set the flag to false. However, as our player exits the grid or the subgrid, we want that to turn back on. So that is the ended phase of the collision. So we have the began and the ended. And ended will occur as you leave the sensor area. So when it ends, we mark it as can spawn, true, and then we set the fill color to green purely as a visual feedback thing for this example. So I've given you a quick rundown on the sensor code. That is the example that I wanted to show you before we looked at the game, because I want people, before they go and look at the game, is to sort of break this apart and step over it and understand what's going on. But again, the key elements are we add a static body that is marked as sensor, and that will set these as to detect only but not respond in any way to collisions. And then we simply attach a regular body to our player, which will allow this object that we're dragging around, or in our game, our ship, to collide with these sensors. So let's take a quick look at the code in the game.
Because we really just want to detect something. We don't really want to interact with it.
We only want to detect what's going on. We don't want to have any kind of response to it. Let me bring up the game, sorry. The good thing is this is a somewhat dry topic, but the next one I think people will find extremely interesting. Okay, so here we go. We got two pieces of code which are going to be a little bit hard to read, but the two critical pieces of code in the game are in Game Lua and in the Enemy Manager, and they should look sort of familiar compared to the last example. In fact, let me bring it up just so you can see it. So in this last example, we had a table where we tracked our sensors. We had a collision listener. We had a function to create the sensor. And then we had some more code below where we actually created the sensors and laid them out. That code exists in Game Lua, and it works exactly the same way. First, we calculate how big the blocks should be for our sensor grids. Then I create a table to store them in. Then I have this function, which is going to be very similar to the one we just looked at, to generate a grid at a specific location. It will put it in an appropriate rendering layer for our game, and it marks it as static. It uses a specific collision filter because our game is a little bit more elaborate. We have a collision filtering system going on, saying that some objects collide with other objects and not. So object A may collide with B, but not object C. So our collision filter here is a little bit more elaborate. And then you notice something a little bit different. Whereas in this example, I said is sensor equals true right in the definition. There's an alternate way to do this, which is after I attach the body, I can simply say, here's my object, mark is sensor to true. And it's worth noting that this is a useful feature because you could, in theory, enable and disable the sensor capabilities. For example, this is a bit of a sidetrack, but you'll recall that I said when it's a sensor, it doesn't respond, it doesn't push, nothing will bounce off of it. There won't be any of those responses that you're normally accustomed to seeing with physics.
Well, a good example of this is the Mario platforms, right, where you can jump through a platform.
Exactly. So you could...
I want to mention that there's a separate method in physics to disable any actions for physics objects. So you don't have to call it a sensor, you disable it altogether.
You steal my thunder. I was going to say, exactly, as Sergey said, there are other ways to enable and disable physics, collision, and responses. And as Charles pointed out, the Mario-style platformer, you could, in theory, implement that using is sensor is set to true and false, but there are better ways to do that. However, you may find yourself in a situation where you wish to turn your sensor on or off, and sometimes I'll give you an example, a very simplistic example. For example, let's say you have a square room with blocks surrounding the room. I can't draw this up for you. And your dude is moving around inside the room, and you just want to keep him inside. But then after some time, you want to let the player or the enemy out. You could mark one of those blocks as sensor equals true, and then you're effectively turning off the collisions. Now again, that's not the best way, but it's a simple way. It's a simple way to do it. So let's back on track. Outside of the definition, I've made it a sensor by setting is sensor to true. I do the same thing with the alpha because I've got the feedback turned on. The grid color, I'll assume that you can spawn there until the collision detection says I cannot. And then I mark it as can spawn true. I attach my on-grid collision listener, which is up here. It's very similar to the code that we just looked at. And I turn it on with add event listener, and I put the grid element into a table that I'm keeping track of. And then in our game, I manually lay these out. Now, ideally, I would do this algorithmically by calculating how many grid elements I need and where I need to place them. But for this game, I decided I'll just lay it out manually. So what I did was I did the calculations in my head, sort of, and I said, okay, I know I'm going to put 4x4 or 8x8 or whatever I decided to do. So I just go row by row, and I put grid elements in. So we get this grid of 1, 2, 3, 4, 1, 2, 3, die, 4. And it's a 4x4 grid, giving us 16 subgrids where spawning can occur as long as it's not set to false. So as in our previous example, we create the grid, and that's all there is to that code. And then in the enemy manager, when I decide that I need to do a spawn, that is the generate code that we've looked at both in this game and in our prior game, we have a piece of code running every 500 milliseconds or so to generate new enemies. So we drop into this code, we check to see if the game is running, we check to make sure that there's a valid player, we cancel the last timer just in case, we do some more calculations here, but eventually we get down to line 138. And on line 138, I create a temporary table called spawn grids. Then I iterate over common spawn grid. Now, common spawn grid is where I placed all of these grids as I created them. So every time I created a grid, I merely stored it in this table, which is in the file common.lua, and I used the an indexing system where I said place it at the index grid. Let me back up. So there's two kinds of indexing in Corona in tables. In Lua tables. There's numeric indexing, and then there is what's the term for it? I can't remember the right term for it. It's where you use any other object type as an index. So for example, I could use a string, or in this case, I'm using the reference to the object itself. So the reference to the object is both the index and the thing I'm storing there. And this makes it very easy for me to iterate over the table and extract an object and then remove that index later. But in this case, it was just easy to write. I could also have written this as, whoops, just so people understand. Oh my goodness. All right. I'm using my keyboard here. People would probably see this as more standard. So instead of writing this code, I could have said, place the next grid element at the number of current spawn grids plus 1. In other words, 1, 2, 3, 4. So this would be placed at 1, this would be placed at 2, and this last one here would be placed at the 16th element. I just wrote this because it's shorter. Common spawn grid equals grid. We know that each of these is going to be unique, and so that's good enough. But back to the enemy manager. So I create a table to contain possible locations to spawn at. I then iterate over every entry in our table of spawn grids. I check to see if can spawn is set to true, in which case I mark the fill color as green, and then I also take that index right here and I put it in my temporary table of spawn grids. So what this is going to do, let me restart this game. As this game starts right now, this piece of code over here will have run, and we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these marked as green, which will then get inserted into this table. So this table, every iteration, as I sit there, will have 12 entries in it. Now, I have a piece of code in here that says if there are no entries in the table, we have no more work to do. So for some reason, we didn't find any entries. So just abort early, do nothing. But I assume that at this point, there's going to be at least one spawn grid having been marked as can spawn and in our temporary table. What I then do is I select one of those grids randomly. And the way I do that is I index spawn grids by 1 to the number of entries in the grid, and I return the object that is stored at that location in our temporary table. So in this piece here, I iterate over all of the possible grids. I select the ones that are set to can spawn equals true. And then here, I randomly select one of those as the place that I'm going to spawn. So you see this little yellow bit right here? As I pause the game, it's probably a little bit subtle. Let me go. There's no way to make this any more bright. Oh, can you see this on the Hangout? This little off-color yellow bit here?
No, I see the grid.
I can see it.
Grid.
Let me ramp that up a little bit. Let's turn the alpha off. That'll do it. It's going to be very bright now. Okay, here we go. Very bright, easy to see. So all of these green ones, and assume for now the yellow one, are the places where we've said we can spawn. And then this little piece of code right here in the enemy manager here has selected one of those to spawn at. And that's this yellow one. So in the debug code, what I did was I said, get the position. Basically, I calculate a spawning position based on where that grid is, and then how wide it is, and where it is vertically, and how tall it is. And then I get a random position somewhere centered around the center of this yellow one. And then for debug purposes, I marked it as yellow, which is 110. So we can see I selected one of the green ones, I marked it as green or yellow, and then I calculated a position somewhere around the center where I said, give me an X between the left side and the right side, and give me a Y between the top and the bottom. So not only do we select a random grid element, but we select a random position within these spawning grids, which gives us a nice sort of organic feel to our game. You don't see things popping in directly in the center of positions. Now, even if the debug were off, if I didn't do this little randomization bit, you'd still sort of eventually say, hey, there's some kind of grid thing going on here, because they're always popping in at these exact positions. But now, basically, when the debug code is off, it will seem as if enemies are just popping in somewhere around you at all times. Not too close, but not too far away. And that's pretty much it. That's the spawning code. So we create a grid. We turn off the response portion of the physics engine by setting it to a sensor. We attach a collision listener, which then listens for a begin and an end event in a collision. And when it begins, a subgrid is marked as cannot spawn. When it ends, the grid is marked as can spawn. And then in our spawning code, we iterate over all of the grid elements we have, and we say, can we spawn at this position? Yes or no. If we can, set it aside temporarily, keep track of it, and then get to the end of that iteration, select a single one out of the 12, 15, however many we marked as can spawn, and then randomly spawn an enemy somewhere near the center of that spawning grid. So what that gives us, let me go turn this off because it's quite ugly. And let me put this back up to full resolution just so we can see it in all its glory. Pseudo glory. What that gives us is a nice organic feel where we can move around and enemies spawn in suitable locations where they don't just spawn right on top of us and kill us, but it gives us a nice sense to this game. As this game gets progressively harder, more and more enemies will spawn, but they're spread out across the board, never directly on top of us, making it playable, but not too easy. So I guess what I would like to close with is that this is a very simple technique for giving your game an organic feel for spawning, as well as ensuring that you never spawn enemies directly on top of your player. And another thing is this is like a level 1 approach. You can now take this same code and start to apply additional rules. You can say, for example, I only want to spawn in grids that are very near to the player but not on the player. So I could expand my algorithm and say only those grids that are directly 1 grid away will be where I spawn. So they're always very near but not exactly on top of me. Or I could say the player has been moving a lot to the right, so I'm going to prefer grids that are to the right of the player, and I'm going to toss these other ones out of my can spawn table. So there's a lot of things that you can build upon from this technique to make even better spawning code.
No, I like that. I also like the idea of making it intelligent.
Yeah, I was tempted to do it for this game, but I thought if I put the code in there to make it even more intelligent like they do in the actual game, it would be completely intractable for people as far as like understanding the code. Because you can see, as hard as it is to read here, this code is quite short. The active code here is, let me just select it. That's it. That's the active code for creating the grid. It's like 30 lines of code.
Mm-hmm.
And then over here in the spawning code, let's just zoom out, the code for selecting where we're going to spawn is like 10 lines of code or 15 lines of code. So I wanted to keep it tractable, something people could dig into and go, okay, I kind of understand how that works. Now I can start to play around with it and expand it and add more logic to it. All right, well, that was way beyond 20 minutes.
Yeah, well, I have one request. When you submit I know you've already submitted the code.
Sure.
When you submit any updates or whatever, will you put comments on those two sections?
Yes, I
Just to
will. Yeah, I haven't given this code the only thing that's missing in this code. I should say it's fully functional, but it's not beautiful. It needs a little bit of beautification as far as like comments that say, hey, this is what is going on. And I want to give it a pass. I've been playing it a little bit here and there just to make sure that there's no bugs still, latent bugs in it. So get the latent bugs out and then comment it up and beautify it a little bit.
Okay.
Yep.
Sounds good. Well, I think we're out of time for today. You want to pick up object caching next time?
I do want to pick up object caching, but I wanted to split it into a two-part segment. So if you just give me 5 minutes for this week's segment on this, and then we'll follow up on it next week. Is that all right?
Yeah, you just want to go into the overview of what it is or something, or what?
Yeah, I do. Because what I want to do is I want people to see this show this week and then go run this for themselves to prove it to themselves. And I'm going to make a forums post on this too.
Okay.
So I only got 5 minutes to see if I can really do it in 5 minutes. So when we started this particular game development episode, one of the challenges is that the game itself produces. Let's run the game. Let's look at looking at the menu. We'll see here eventually. We'll start to see some explosions going on. So we see these little explosions. These explosions that are just these little bits that are going on here, or when I run and play the game, you'll see we got all these particles, right? These explosions and bullets and stuff like that. This game produces a tremendous amount of objects as explosion pieces, bullets, enemies, etc., etc. And so the question occurred to me is there some way we can make this game more efficient? Because we're going to be producing tons and tons of display objects every second or every frame. And I know that I've heard a lot of times in the forums people say, oh yeah, what I do is I cache my objects. And I'm like, I'm not 100% convinced that caching is the best technique. Not because I poo-poo the idea so much. Caching is a great idea. It's just a question of return on investment. So in a nutshell, what caching is, or object caching, is you create an object that you know you're going to create a lot of in the future. You create it, you use it, you're done with it, and instead of destroying it with a call to remove self or display remove, you simply say, okay, I'm done using this object. Let's just move it somewhere off the play screen or do something so that it's not in the way, it's not interacting in my game in any way, but it's just sitting out there being ready to use again. And then the next time you create one of those objects, you have a table or something, and you say, look, I've got a free one that's not in use, so I'll bring it back to where I need it, set it to the right color, make it the right size, do the things that I need to do to make it look right, and start using it again. So in essence, the more you create, the more you have, but at some point you'll reach a level where you'll never create more than you need, and they're always either cached or in use. So I think I have like 2 minutes left. What I did here was I wasn't convinced of this at all until I made this example. See, the problem is with the game, there's really no good way to test this where you can say, yes, for sure that is making it better. There's no question that caching is better, or it definitely doesn't make a difference. So I made a little test bench using some of the code from the game, simplified. And what this code does, I want people to take this code, I will give a link in the show notes, run it on your device, install it, and every time you want to run this test, you got to quit the app and start it over again. It's a one run only. And the way it works is you run the app, you let the sensor, you let this frame counter get initialized, so you start to see some numbers here. And then you say, I'm going to create object 1, 2, 3, or 4. These are just little text objects, and you click on them. So, for example, 1 is circles, and that will both select 1 as you're going to be creating circles, and then it removes the button. So it's a very simplistic example. And then how many do we want to create? Let's create 500. So I've selected circles and 500 now. And then finally we have to decide, are we going to use caching or no caching? So let's use caching. And what that's going to do is every other frame, it will try to create 500 circles. It will randomly color them and place them on the screen. And because we're using caching, when I remove those from use, they will become uncached and they'll get put somewhere out of sight, out of mind. So on the second frame, I remove them all. And then on the third frame, I create 500 more. But now because I'm caching, it says, oh, I've already got 500. So I won't create new ones. I'll find the ones that are in my cache. I'll put them back on the screen and reuse them. What I want people to do, I think I'm up to my 5 minutes, is take this example and simply install it on your devices and run it. And you tell me, or you decide for yourself, if caching or no caching is better. I'm going to give you one hint. When you run it in the simulator, the frame counter is not so good. It doesn't give you a good sense because you've got an overwhelming amount of compute power. You really want to do this on your device. And the other thing you want to do is choose a number, not where it's at 60 frames a second, but where it runs, and it runs at many fewer frames per second. In other words, run the example until you're not getting 60 frames per second. So, for example, on my device, I'll run example 1, and I'll run like 700 circles, and that'll dip way below it. I'll get to like 16 frames a second. So attempting every other frame at a rate of 60 frames per second target to create 600, did I say? 600 circles, and then delete 600 circles on the next frame is too much. It taxes my system, and the frame rate starts to drop. What you want to do is find a place where the frame rate drops for caching, and then repeat that same test and use no caching. So let the frame rates drop. It'll settle out at like 16, 15, 20, whatever the number is. Let it run for a little bit, then write that down. Then run the same test, quit the app, run the same test, but choose no caching, or the opposite. So if you've got caching in one case, use no caching in the next choice. Let it run, let it settle out, and write down the frame count or the frame rate. And whichever one is lower is the loser. So you want to crush the system. You want to tax it to the point where it's not behaving well. And then the one that behaves least well with the same settings other than caching is the loser. And I won't tell you what my findings are this week. I was extremely surprised. So that's a bit of a hint. I was very surprised. And that's all I'll say. Okay.
All right. Well, we'll leave it there. We'll leave it for an exercise for people to come and do. Everybody in the panel here should at least run it, and we'll compare results. We'll see what happens.
Yeah, I'm gonna make a forums post, and I'll give you a link to it.
Yeah.
Because I'd like to see if we can gather up some metrics from folks where they tell us, oh, I ran it on my iPad 3 whatever, or my Nexus 7. So that I can see some different values, because my sense is we're going to see different performances on different devices.
Right.
Not just raw numbers, but like caching will be okay on one device, and on another device it makes no difference. That's my sense.
Interesting. All right. Well, I have some questions, but I'll hold them till next week. So thanks for everyone for being here. We will be back here next Monday at 12 p.m. Pacific to talk all about cross-platform application development using Corona SDK. Until then, the links will be in the show notes, so download that and play with it, and have a great week, and happy coding.
Auf Wiedersehen.